All right, so um, today's video is a quick recap, or I guess further explanation of how I approach a more complicated equilibrium problem. So my first step is to look at the given picture, right? Because I'm gonna mark this picture up so that when I move to write my or draw my free body diagram, I can organize it as a separate step. So I don't have to organize the forces on here and come up with them at the same time. So the first thing I look at is, where is this body attached to something? So where are the supports? In this problem, this is a support. So there's a support at A and there's a support at B. So looking at each one individually, we want to break up essentially what they do, and then based on what they do, we're going to come up with the reaction forces associated with it. So this is a hinge. So at A is a hinge. And a hinge, you can model this by like pinching the bottom of your paper, right? So if you're holding the bottom of your paper in one point, like a hinge would, you can rotate the paper, but you can't move it up or down. So the idea is behind reaction forces that because you're allowed, like you're free to rotate the paper, there is no force preventing it from doing that. So similarly, because I can't move this up or down, that means this fixture here, this support, is providing a counter force to hold it from going up or down. So there is a force here in the vertical direction at Y, or at A, sorry. Same thing left and right. I can't pull this beam left and right off of this pin because it's pinned there. So for that reason, there is a horizontal force at A. But there's no moment because this body is free to rotate, meaning it can, if I push up on this side, it can swing up and there's nothing preventing it from doing that. So this next force, or this next support, is a roller, which means if this was free, I could slide the beam across the roller in the X and Y, so there's not going to be a force counterbalancing the X and Y, and I could essentially pivot it so that it was like this or like this, so it's free to rotate around this point, assuming this is gone, but it's free to rotate about this point, which means the only thing it's not free to do is move down like through that roller. So that means there is a vertical force BY. So that's the first step. My personal next step is, while I'm here marking this whole thing up, right, I'm going to break up all of my forces into its components. So here is the vertical component of this force, and it's also got itself a horizontal component. This one's fully vertical. This one has a horizontal and a vertical. So what would the vertical component of this force be, of the 450? Well, this is the same thing as this side, right? It's the height of this arrow, which means it's opposite this angle. So the vertical component would be 450 newtons times sine, because it's opposite the angle, 60. The horizontal component, since it's touching the 60, would be cosine. So 450 newtons times cosine of 60. 300 stays the same, so that's just 300 newtons acting straight down on point B. And then 700 I need to break up again. So because the vertical component on this force is the part that's touching the 30 degrees, that's going to be my cosine, because the fact that it's touching means it's adjacent to the angle. So the vertical component on this one is the cosine. But because this horizontal component is the same as if I were to draw it up here, it would mean that it is opposite the angle. So here, this component is 700 sine 30. All right, so now that I've got all my forces broken up, I'm going to, oh, I'm just kidding. We have one more force that we need to consider, and that is the moment that is acting on this beam, and it is 1500 Newton meters. So now this is not my free body diagram because this body is not freed. So the free body diagram implies that this is no longer attached to anything. So it is freed from all of its supports. So now we have to draw the free body diagram. Always label it so that they know that like this is your final answer, because there's some problems where you're going to want to draw it a couple times, finalize it, whatever. So in a perfect world, you're going to use a straight edge, and like on your exam, you're going to use a straight edge. But I have a little writing pad thing, and I can't use a ruler on it or else it'll start writing. So I have to it'll be wobbly, but it'll work. So here's the reaction forces. So this is our body, right? We're not going to draw the pin. We're not going to draw the roller because it's freed now. So here's our body. This is AY. This is AX. And then here is BY. Okay, and then we have our force components. So here is our 450 sine 60. And then here we have our 450 cosine 60. Same thing here, we've got our 300, which is just the 300, no sine or cosine because it's straight vertical. And then here we've got our 700 cosine 30. And then on the horizontal, we have 700 sine 30. And then we have our moment. You can't forget your moment because that's still a force. So then 1500 Newton meters. And then what else do we need? So we've got our forces labeled. We need our assumption for what's X and Y, or like what we're calling positive. So I usually tend to put up and to the right as positive, but that's a personal preference. The last thing we need is dimensions and the points. So here is point A, here is point B, and here is point C. So you need your points so that when you're doing your math, you are labeling things according to how your professor is going to grade your exam. So you could call this PQRS, or you could draw labels and smiley faces or whatever you want to do, but the idea is that you're using those as indexes in your work later on. And the last thing we need is dimensions. So there are our dimensions. Okay, so I like to, right under my free body diagram, establish what my knowns and my unknowns are. So my known values are the ones that have obviously numbers on them because those were either given or derived. But my unknown values are going to be what are labeled with variables. So my unknowns, I'll write it over here just to save space. So my unknowns are AX and AY and BY. So because I have 3 unknowns, that means I'm going to need 3 equations to solve them. What are those 3 equations? Well, there's the sum of the X direction, sum in the Y direction, and sum of the moments about whatever point you want. And I'll explain this one in a little bit because this one is the one that people kind of tend to be confused by. So, all right, so I don't care what this picture says anymore, okay? And then as long as it says that the question is reflected in my unknowns, so it says determine the reactions at pin A and roller B. Here are the reactions at pin A, and here's the reaction at roller B. So as far as I'm concerned, this is the problem now. I don't have to look any further. So let's just jump right into it. So solving for AX, how do you do that? Well, it's the sum of the forces in the X direction. And because this is equilibrium, all of these will equal 0 because they're not moving. There's no force pushing it in the, or there's no net force pushing it in the X or Y, and there's no net tendency to want to rotate. So I'm going to solve for AX right here. And this doesn't have to happen in a specific order. I'm just picking them as I go. So AX is the sum of the forces, sum of the forces in the X direction equals 0. And then you have to define again what you're calling positive and what you're calling negative. So I'm calling to the right positive, and this little line through it, I remember that has to go there because it makes the arrow look like a plus sign. So then the sum of the forces in the X direction equals 0. Well, AX is pointing to the right, so it's positive. 450 cosine 60 is pointing to the right, so it's positive. These are all vertical, and then 700 times the sine of 30 is pointing to the left, so it's negative. And then all of these, so this becomes your equation. You can ignore this equal sign. But then if you solve for AX, you'll find, or if you move AX to the other side of the equation, you can solve for it. So then it would be 700 sine 30 minus 450 cosine 60. A couple reminders. So that's AX works out to 125. And then all of these are in newtons. And because it's a positive value, it's to the right. So I'm going to create another video after this, going over some things that you need for every answer. But as a reminder, you need the value that you just found, you need its magnitude, its units, and its direction. You technically also need its point of application, but because it says A here, that means that I can look at the corresponding free body diagram and find where it is, and then boom, I know exactly where its point of application is. All right, so now I have AX. AX is a known. Boom. AY and BY. How would you solve it? Well, a lot of people think you would solve it by summing the forces in the Y direction, but I only have one equation and I have two unknowns. So the problem with that would be that's essentially saying the same thing as, let's say X plus Y equals 4. Okay, now tell me what the values for X and Y equal. Right, so that could be 1 and 3, that could be 2 and 2, that could be 64 and negative 60, like that could be so many different values. But we need it to be a specific one that ensures that this beam is not rotating or moving in any way. So that's the reason why we can't jump right into the sum of the vertical forces. What we need to do, we can't use f of x because, or the sum of the fx forces, because those are all moving in the x direction and that doesn't help us. So the only thing we're left with is a moment equation, right? So this is kind of up to your discretion, right? So you can take the moment about any point on this beam. So you could take it at A, you could take it at B, C, or whatever this little intersection thing is. It wasn't labeled in the original, I don't think. No. So you could take it at any of the points where you have a dimension, right? That's all you need. The idea, though, is that you're trying to use this moment to eliminate one of these unknowns so that you can just solve for one of them instead of both. So in this case, it would only be useful to solve it at A or solve it at B. So I intentionally did A of X first, kind of because in class we did the moment first, and we chose to do it here because it eliminated both of these unknowns. But I wanted to show that you could do it a different way, so I'm going to choose BY. I'm going to take the moment at B. So I'm going to solve for BY. I'm going to say the sum of the moments about point B is 0. And just for my own reminder, I'm going to say clockwise is positive. And again, you draw the little line through the arrow so that you're establishing that as your positive convention. So now I go through every single vertical force every single vertical force and multiply it by the force times the distance from B, right? The reason why I don't include horizontal forces is because all of the horizontal lines of action go through point B. So all of their perpendicular distances would be 0. So looking at left to right, so AY points up. So if I pin it at B, it pointing up would want it to rotate clockwise. So it's positive because I called clockwise positive. So AY times, oh, I goofed over here. That's supposed to be an AY. And you'll see why in a second. So AY times 2 plus 4, so 6. And then 450 sine 60 is pointing down. If it's pinned at B, that'll make it want to rotate counterclockwise, which is opposite my convention. So I'm going to leave it negative. And that one's only 4 meters away, so it's times 4. We have a vertical force By, but that is the perpendicular distance between this and B is 0. Same with this 300 because both of them act right through B. And then 700 cosine 30 is, I'm pinning it here, I'm pushing it down. That makes the beam want to rotate clockwise, so I'm adding it. So 700 cosine 30, and that is 3 meters away. And then there's an overall moment acting on this force, or acting on this beam as well. And that is causing it to rotate clockwise. So I have to add that just like that. So because this is already in Newton meters, you don't multiply it by a distance because it's already a moment. So that'll be indicated by this arrow being curved, but it'll also be indicated by the units. So be careful because you can't ignore it because it's still causing the body to want to rotate, but you also have to make sure you're not multiplying it by any distance because then it's not a moment anymore. All right, so then we're going to rearrange this so that AY equals a whole lot of stuff over 6, right? Because I'm just dividing this. And then if I move all of these over to the other side of the equation, it flips the signs. So 450 sine 60 times 4 minus 700 cosine 30 times 3 minus 1500. And that will equal AY. I'm going to plug that into my calculator right now. So 450 sine 60 times 4 minus 700 cosine 30 times 3 minus 1500. All that divided by 6. So I got negative 293.3, so I can just round it off like that, Newton meters. But because I called this convention as clockwise being positive, it came out negative because the reaction force here would be counterclockwise. So that means I have to switch it so that it's positive 293 Newton meters counterclockwise because it's opposite of my assigned convention, and then it's about B. Oh wait, oops, man. And then equals, oh wait, hold on, I messed up. So we're solving for AY, which is not a moment. Just because we're taking the moment doesn't mean we are solving for one. So I forgot that by dividing by this 6, I'm canceling the meters part. So then it would just be newtons, which makes it a force, which should be a force because it's AY. So that's my bad. But again, because I called my assumption here was that it's pointing up, and that's what I used in this, it came out wrong. So then that means it's actually 293 newtons pointing down, and then it's at a y, or it is a y, but it's at point A. So that is our answer for that one. So now this is a known. If you have any questions about that and how like I got from here to here, because I kind of explained it wrong, just email me and I'll explain it again. But so now that I have this AY, my only unknown left is BY. So that just means I can take, to solve for BY, I can take the sum of the forces in the Y direction equaling 0. Again, my convention is that positive is upwards. So now I just take the sum of the forces in any vertical direction. So I have positive AY, which I just said was 293, but I actually found that it's pointing down, so it's negative 293. And then here I have a negative 450 sine 60. And then here I have a negative 300 and a positive BY. So negative 300 and a positive BY. And then a negative 700 cosine 30. Minus 700 cosine 30. So solving for that, BY equals 293 plus 450 sine 60 plus 300 plus 700 cosine 30. And quite frankly, I have a feeling I messed something up with a sign because that seems like a really big number. But we'll find out. Maybe I'm wrong. So I have 293 plus 450 sine 60 plus 300 plus 700 cosine 30. I got 1588.9, which I don't recall that being the answer from last time, but let me double check. Oh, for the record, I am not looking at a solution right now, and I'm trying to make this a short video, so there's a definite possibility that I messed something up. So let's check the answer key. Oh, I did not mean to stop sharing. So let's check the answer key. Here we go. And I want modules. And this was equilibrium. And it was 2D option 1. All right, let's see. AY, oh, that was right. So BY is massive, I guess. So here's that, and let me pull this down so that we can confirm all of our answers. So here we have one, or here, I forgot to box this one. So, all right. So AX is 125 to the right, perfect. AY is 239 down, or I'm sorry, 293 down, and BY is 1589 up. So a couple quick things. Technically, I would have gotten points off here because this is, no, this one's fine. This one should be 125.0 Newton to the right because of the sig fig rule. Same thing, this should be 1589 Newtons up because of sig figs. So there's that. I'm going to create a new video so that they're all kind of shorter instead of being one long video. And in that video will be, in that video, I'm going to talk about some of the things that need to be there in every single test question or every single solution you have for a test problem. So definitely watch that because that's going to be how you maximize partial credit and how you keep yourself organized.